All right, so I was able to run that query. I think it just froze up. It does take a few minutes to run, right? So one of the advantages of this technique is that it's creating a virtual table. But one of the disadvantages is that that virtual table needs to run every time the data is created. So if I save this and I close down QGIS and I open this back up, then the query has to run as it opens. Same thing happens in ArcGIS, by the way. It's not like unique to QGIS. The difference is that since ArcGIS requires the database to be actually on another database machine, the database machine is the one handling the query. So typically you get a beefy machine to store all your data, and ArcGIS dispatches the query and then gets the features back. And it really does work well in an enterprise environment where, like, let's say these represented some feature that was changing over time. Then every time I opened up ArcGIS again, that feature, those features would be updated. The symbology would be updated, and I always have that ability. I wouldn't have to rerun some spatial join tool. I just did a spatial join. I wouldn't have to rerun the spatial join tool because I've turned that into a command, a single command. Every time ArcGIS opens up, it can dispatch that command. It saves the command, dispatches the command, and gets the results. So here's that final query for the spatial join of the two layers. By the way, SQL is not even, white space is totally not an issue with SQL. So you can, what I like to do often is put every keyword, every clause on a separate line. I like to do that. So it's a little bit easier to read there. So you have it set up, and what you're doing is you've got your select statement, and you list all the columns that you want. In this case, I want to have the geometry column from the counties, and it's just going to give me the first one. Okay? Then I'm going to get the count of all of the point geometries associated with those counties, or with the TRI points, the toxic release inventory points. And then I want the county name. So I get all three of those. Then I list the tables. They're coming from these two tables. Then there's my where statement. And in this case, my where statement is a spatial join. It's saying where the geometry from the TRI points intersects the geometry from the counties layer. And then finally, I'm grouping those by the county name. And as Elvis pointed out, it'd probably be more appropriate to group those by a county ID. But I would get the same result in Mississippi. I wouldn't, since the county names are unique, I would get the same result. Okay. But that's the full SQL statement. So, I mean, all I did was put returns in, but I could hit add and say yes here, and we can see how long this takes to, there, see it finished. That's how long it should take. It did take, 3 or 4 seconds, but, and then it takes another few seconds for it to actually draw. There, now it's done drawing. So altogether, it probably took 10 or 12 seconds. Okay. But you can imagine if these, instead of having 818 points, we had the tornadoes. I'm not sure how many tornadoes we had, but we had a lot of them. So we had those 818 facilities, right? So I could modify this. So see this active STA column? some of them aren't open anymore. Some of them say that they're closed. So what if I only wanted to count those that the active STA, which probably is active status, are true? I could go back into the virtual layer and say where and add an AND statement. And, so this is really part of the where clause. Where as active STA is equal to, quote, open, quote. So now I modified that slightly, and I hit add. I want to overwrite it. And now I'm only going to get those open TRA facilities. It didn't change my data too much. Let's see what happens when this finishes loading.
Can you put density by counties?
There it goes.
Density by county per facility, being that you got 20 in there, but
Yes, yeah, I could do density, right? So that finished drawing now. So by the way, it didn't change it that much to say most of them were open, but that's just an example of doing that. So yeah, so for Elvis's question there, could I do density? Yes. So here is the count as try count, and then I could add another field called, well, I would say count TRI dot geometry, and then just divide that by ST area of the CNTS dot geometry. So now I'm going to get the number of dots per county. I'll just call that as density. I could even call it TRI density. So now I could run that. I wonder if that's how I messed it up before. So now I'm trying, okay, so it should have that other field. Maybe it's still processing. Should have that density field that I added. Didn't actually add it. So divided by ST area CNTS dot geometry. Okay. Let's see. Okay, this time I'm just gonna wait for a second before I try to open it up. There we go. So now it's started to redraw. I'll wait for it to completely draw, then open the attribute table. So now that it's redrawn, yeah, I do have that density field. So this is the number per area, the count per area of that.
Symbology, is that the symbology that we're looking for?
No, the symbology hasn't been updated. And actually, yeah. So if I wanted to update the symbology, I'd have to tell it to do the density, and then now I hit classify, and it's going to have to go through that field. Since it doesn't actually exist on disk, it actually has to it's calculating it. And now I say, okay. And now I've symbolized it using that new. So this is symbolized on the number of open toxic release facilities by county. That's what this symbol is. Okay. So very similar to what we did with the tornadoes and the hexagons that we created. Okay. So that's a spatial join. All right. So for today's lab, what you have to do, this one has a spatial join, and it has a modified where clause. Okay, so I'm going to go ahead and close this down because I think that having two of those open may have caused some of the issues. So if you go to the lab, first of all, I have some links. So QGIS actually implements SQLite, but I like the PostGIS reference better. It's easier to read. There is some differences between SQL implemented in PostGIS and SQL implemented in SQLite, which is what QGIS implements. So sometimes there won't be a particular function that exists in one or the other, but I have both of them referenced here. So you can look through those. Now for the lab's pretty cookbook this time. Like you just follow it through. The only exception is towards the end of the lab, I have you modify an existing SQL query to change it slightly. Okay, so here's the lab. I have a Word document that has the text of the lab and then the data itself. Okay, so you download the data and then you can open up the lab and just follow it through. So I've given you a copy of this. This is basically the schema for each of the layers that you're going to deal with. You're actually not going to deal with all of them. But the first thing to do is to just add them all in. Okay. So here I'll do that part. So go to layer, add vector layer, and then go to the data sets where you unzipped it. I unzipped it into temp data, and then you want to load in the census blocks. You want to load in the socioeconomic data. You're eventually going to use homicide, so if you want to load it in right now, you can. You're not going to use it until the end. And then neighborhoods, streets, and stations. So all the shapes plus NYC census socioeconomic data.dbf. You're not actually going to use socioeconomic. I put that in there as an example of a regular join, but I messed it up. So anyway, I can fix that later, and I can show an example of that, but not right now. So you add all those, and you say OK to this one, just saying which geographic transform you want to use. So now you should have all the data. And the reason I didn't have you add homicides in first is because there's this single error in the homicides data. So if you do add homicides in now, the extent is messed up because there's this 1 over at 0, 0. So just don't use that. Anyway, zoom in on the other data. You could actually right-click on like any of the other data sets and say zoom to layer, and then you'll have it. You might want to arrange things better. Like I'm going to put the blocks down here. The neighborhoods are going to be at the very bottom, and then the homicides I'm going to turn off for now. I've got my streets and the subway stations. Put the streets above the subway stations like that. There we go. Something like that. Right. So now I've got all the layers that I'm going to deal with in the entire lab. Okay. So then I could go ahead and save this as a spatial SQL lab, something like that. Hit save. All right. Okay. So at this point, you're ready to open up the dialog box to do the spatial queries. So I'm going to uncheck these guys. You could leave one of them on if you want. Like that one might be the best one to leave on, just to kind of show that you're still zoomed into the right area. And then go to settings, layer, and add the virtual layer. All right. So here you have to make sure that you import. You can go ahead and import all of these layers. Import, and then just hit select and select all of them. So now you've got them all in there. You might not be able to see them all, but they're all there. And to make the lab less complicated, I didn't rename any of these. So the lab is pretty basic at this point. Once you get to this point, you're good. I'm going to go ahead and hit close, so that it, for some reason when you hit close, that's when it saves it. So now you'll be able to go in here at any time, and you'll have those same layers loaded. So now in the lab, we're already through this point. See how I don't have homicides there, but it's okay. Okay, so now the box looks like this. So now the lab is all about just reading about what these queries are doing, and then taking the data, taking the query and pasting it into the query window. But not that one, because that one's just the general term. I just saw it. So that's the general query. So it's kind of teaching you as you read through the same kind of things we talked about in class. Right? So here we've got our data set, and we right click, we put the thing in, and we change the virtual name to Brooklyn Neighborhoods. What does this query do? Either by just looking at it, or you could go read the lab. What's that query going to do?
Selecting out the neighborhoods that are also associated with Brooklyn.
Right. So in the borough name attribute, they have the value Brooklyn. So it's only selecting the Brooklyn neighborhoods from the neighborhoods data set. It's only selecting the ones that have an attribute Brooklyn in them. It's basically the Brooklyn. So if I just hit add here, and I could close this if I want to, because it saves it. So now it's made a new virtual layer, and if you were wondering where Brooklyn is, that's where it is in New York. Yeah, so that's it, and those are the neighborhoods that have Brooklyn as an attribute. Now, Brooklyn isn't a donut or a bagel or whatever this is. You know, they probably sell lots of donuts there. Brooklyn. Let's see why it has that in there. I think it's because it's like it's this. Oh, no, it's not that area. I think it's just an error. I think the data left out a neighborhood, but that's in the original data set, so you don't have to worry about this. You don't have to worry about that missing value. Okay, so that's Brooklyn, and you've done that so far. All right, so the next thing you're going to do is just follow this through. So how many neighborhoods are in Brooklyn? And I mean, how many are in the table? Okay, so how do we do that? How do we find that? I'll give you a hint. So open the attribute table, and you can find the answer right there. Right, so that's the right answer. Okay. So there are 23, and then you just follow this through. Okay, you're gonna ask. You're gonna use a different. You're going to use a string function called length. And here, now you're going to have the length of the name Red Hook. So it's, 1, 2, 3, 4, 5, 6, 7, 8. It's just an example. It walks you through. You'll do more and more things. You're gonna eventually get to doing spatial joins with SQL at the end. Okay. All right. One thing that I didn't do was really show overlay. So I'm gonna stop this here. You guys can continue on the lab portion of the of the thing, but I'm gonna do some overlay really quick, right? So look at all these using SQL. Look at all these points. Those points represent subway stations, right? So let's say I wanted to ask the question, what is the total area of each borough? Sorry, I could do it by borough. It's true. You could do it by borough. What's the area of each borough that is within walking distance of a subway station? Let's say that, right? And I can't really do network analysis because I don't have that. So I'm just going to define walking distance as somewhere you could get to in 3 to 5 minutes. So somewhere around, let's say, 400 meters. Okay. So 4 football fields in length, you could get there in about 5 minutes. All right. So in order to do that, I need to first find the areas that are within 400 meters of all of the subway stations, right? So I've got all my subway stations. How would I do that? How would I do that using tools in ArcGIS?
You buffer around your subway stations.
Right. I'd buffer around the subway stations, and we could do that in SQL. So I'm going to go to Layer, Add Layer, and go to Add Edit Virtual Layer. So I can modify my statement here and say select star from subway stations. From NYC _ subway stations. Okay, so instead of star, I could say ST _ buffer, and then do the geometry. Now the buffer buffer requires a distance, so I'm going to buffer the geometry. What did I say, 400? So now I'm going to get a buffer of every geometry by 400 meters. Okay. So I could do that. And then I could just see what it looks like. I'm pretty sure this is going to work. So I'm just going to call this buffer subway. And then add that. Oh, it didn't work. Geometry. I spelled it wrong again. Okay. Add. All right, so there's my buffered subway stations. Now, if I wanted to dissolve them, I need to merge them all, right? Using that union command. But I also need to group them by everything. Group by all. SQL. Grouping by all the columns, yeah. Group by star. Okay, so that's what I'll do. So I could say group by star. I think that's what I want. And then I'll do ST union. So now what it's going to do is give me, it's going to basically dissolve all those buffers. Did that actually run yet? Whoops. Edit virtual. No. Attribute 2. No. So group by star isn't what we want. Hmm. Single group. That's what we want. Hmm. Group by group everything into a single group SQL. Okay, well, I mean, we could create a column that does that in the I mean, we could create a new column that has everything already grouped. Let's see, group. Let's see if there is a column that we could use. Buffer. So that would be the stations. Object ID. Closed. Yes. NGHBHD has everything. Is already a column where everything is empty. NGHBHD. Group by NGHBHD. Okay. All right. So let's see what happens if we do this. Yeah. Okay. So it took off my ST union. ST underscore union. And then now we should get what we want. Yeah. Okay. Yeah, that worked. See how I was trying to dissolve all the boundaries between the polygons? So now this is a single item in the attribute table. There's only one item in the attribute table, and it's all of the it's all of the buffered area. Okay. All right, so this is an example of, we could keep building the SQL query to then find out how much is in each neighborhood, okay, as one single query. Or we could go into the editor and add another table that looks at this table and then calculates that value. So we've done the buffer, and now we need to do the overlay. So here we could go in and do another virtual layer and import our buffer subway. So now we have the buffer subway layer. And what we could do is say, oops. I don't know what I think I just bumped it. Is buffer subway still there? Nope. Oh yeah, buffer subway still there. Okay, so now we could go select buffer subway. Sorry, we need to say st intersection. So intersection will actually return a geometry that is the intersection. Because what we're trying to do is intersect the buffers with the neighborhoods. So we can say I want to return an intersection of the of the buffer subway dot geometry, comma, NYC neighborhoods dot geometry as geometry. And then I could say from, and I need both the tables, buffer subway, and I need the NYC neighborhoods. And then I do need to have a where clause. So I need to say where they intersect. In other words, I need to do a spatial join. So st underscore intersects. And I can actually copy this because it's the exact same information. And that should do it. So I'm taking the buffer, and I'm gonna basically say I want the intersected area. That's what this is, between the buffers from the subway and the New York City neighborhoods, and that's going to be my new geometry. I also probably want to get the neighborhood name, so I'll just say comma name. So now I'll get the name of the neighborhood, and then I'm going to call this buffer subway n overlay, and then have that guy. Whoops. Okay. What does it say? I'll test it first. Okay. Please specify at least one source layer or a query. So it doesn't like my wait, I don't say anything about homicides. I wonder what that was all about, but okay. Maybe it's because that layer was over there. All right, so now it's kind of hard to see. Let's turn off everything else. But that query, you could see what it did was it returned the area. It returned the buffered area, but now it's split out so that, I don't know why it's not drawing quickly, but it was split out by neighborhood. And I probably successfully got it to freeze again. Let's see what happens. So the difference between intersects and intersection is this returns a new geometry that is the intersection between the two geometries. And this returns a true-false statement that can be evaluated as yes or no. And so the where clause needs a true-false statement, but what I actually want to see is their intersection. So that's how I did a overlay in SQL, using SQL.
Can you repeat the difference between those two, but point to it on the video?
Yeah, sure. So the intersects returns a true false. So if I go to the help for, this is the post-GIS help, but it's really the same as SQLite. But ST intersection takes two geometries and it returns a geometry. Okay. But if I go to ST intersects, then it returns a Boolean. So if a geometry shares any portion of space, they intersect, and it returns a Boolean. So here, where the where clause needs to be a true or false statement, just like if you did a regular join, you would need an ID to be equal to another ID to join it. So the join part needs to be a true-false statement. So intersects is the right one to use there. But if you want to actually see the intersection, then you need to use ST intersection, which returns a geometry. So this is going to return a geometry out. And again, I don't know why it is. I mean, it is a fairly complex thing that's going on. It's not just doing, it's doing the buffer and the intersection, they're all virtual. So every time you zoom in or zoom out, it needs to redraw those. So.
I have a quick random question.
Sure.
I'm importing the census social data, and I was just kind of wondering which file, like do I do a DBF or the XML? I know one of them's right. You have the data shape file?
The DBF.
Okay.
Yeah, and again, I messed up that data. It's not, that was for a demo. You're not actually going to use it in the lab, but I messed that data up. All right. Well, sorry that this didn't show. It did work, but when I tried to zoom in, I think what's happening is that every time I zoom in, it's running that query over again, and so it like got into a stutter. As I zoomed in, it like tried to redraw it like 5 times, and so now it's in this loop where it's trying to redraw and refresh itself. But you get the idea. You could do it, and if you had the computing power, it could be an asset. But one of the advantages to doing it the tool way, especially if it's a complex thing like this, is that it saves out the intermediate steps. That's also its disadvantage. You have these intermediate steps saved out. What do you do with them? But here, every time we zoom in and zoom out, it's recalculating it. That's kind of a pain. All right. So, any other questions? The queries in the lab, until you get to the end, there aren't very many complicated queries. When you get to the end, there are a few that take a few seconds. So try not to zoom in or zoom out too much when you get to those, because you might, if you experience this, you could just shut it down like this. Close window, close the program. That's what I did. That's what I did between the break, and then I just reopened QGIS. But I don't think it saved any of my results. So here's that one that I just ran, and it didn't. It didn't save any of my results, and I'd have to. Let's see what it says if I go back here. Nope. So I'd have to re-add everything to get it to work, to do that example over again. All right. That's why it's important to save. Okay.